Welcome to my channel, everyone. This video is going to be part 3 of 3, and I'll show you how to wind, make all the connections on this circuit of mine using one of these strip boards. It just makes it easier having it set up this way, and then you can literally copy exactly what I've got on the schematic there as well. Before we get into that, I want to do a serious section of this video to highlight the importance of being careful. Whilst this may seem to most people to be nothing more than a lighting circuit, it does have some strange characteristics that would leave a normal understanding of electricity might get you into a bit of trouble with this circuit. If you were a bit too relaxed, you may end up getting electrocuted just because you'd think that something is not connected when it actually is. So here we have capacitors. There's two capacitors in parallel there, and they're not currently connected. Here we have a connection that I'll make to the battery. So it'll be one wire going to the battery, and that also demonstrates Tesla's one wire concept. DC transfer, it doesn't have to be two wires for DC. And so we've got this bridge rectifier connected to those capacitors. We've got a voltmeter that shows that there's nothing in them. I've just shorted them out. And then so from the bridge rectifier we come over to one of these coils that we've seen before that picks up the wireless from this main circuit, and it's very similar to this type of setup here. Same amount of turns, same capacitor. So we'll put that back there. I leave one of the lights on the circuit at all times because like I said, it can be dangerous, and I'll demonstrate that in a second here. So we've got main circuit. Out of the main circuit we have this yellow jumper lead coming off the high side of the secondary coil. We're going to connect that to earth, which I've created by partially unwinding this coil of wire here, and that's probably, well, the roll was originally 100 meters. I've taken 10 meters off of it to make one earth ground, which I will demonstrate here in a second. And then so this would be primary earth, and then I have a secondary earth as well, which I'll add into this circuit in a second here once we see the differences between different earth points and their relevance. So at the moment I have these neon bulbs that I pulled from I think these came from a rice cooker, and I believe, without checking it, I think they take around about 70 to 90 volts to make them light up. So far the only place that they do light up on the circuit in its current configuration is on the high side of that coil. Sorry, my mistake. Low side of the coil. Yeah. So low side of that coil, we can see there that those are dimly lit. But yeah, that presents there's a high voltage. So if we look over here, there's nothing to the not currently connected capacitors, nothing. So none of the other wires seem to present that high voltage field, not even right beside the coil. So if we now take this yellow earth lead and I'll connect that up to earth, so this is low voltage side of the coil of the output for that coil, and so the circuit's still oscillating. We have those lights to show that. Now that we've added that earth ground, we come back to these neons, you can see the difference that having an earth ground makes. So before we only had one wire that was giving us that high voltage feed. Now it's every wire except for the secondary coil, which is that wire there. So the only wire that was transmitting that high voltage before is that wire, and now that wire doesn't transmit as soon as I've connected earth, but every other wire does. Not only do the other wires transmit, but everything around, including the battery, absolutely everything becomes alive. So this is why I want to focus on safety here for this. If you go building something like this, your safety is your own responsibility. This can kill, and just because you can't see it doesn't mean that you're not in danger. So now we can see that that field is present just about everywhere on that circuit. So now what we can do, if you touch it directly to some of these things, like if we get a direct connection to the metal there, they glow quite brightly then. Possibly the same with the earth. They're quite dim there. So just about everywhere in the circuit now has this high voltage field present. What's that done to the capacitor? Capacitor's now climbed to 25 volts DC, and that's not connected to anything at all. That's connected to this coil. Other than that, there is no physical connection with the remaining circuit. All right, and we've got 25 volts there, and it's not a measly 25 volts. It has some backing behind it, and we'll short that out. So we can see that that's decent. Anything above, too high voltages and it'll do damage to the meter. This will not be the first meter that if I'm not careful I will end up sacrificing. So left alone, connected to that coil, the circuit will pick up that radio field that we can see with these neons. And they're a handy thing to have because you can detect things that you can detect the field and work out what's safe and what's not safe, and you know, it's quite possible that some of this stuff won't show up with a normal AC safety probe. So so we've seen the just the radio collection there and that building and that capacitor. Now if we place this white jumper lead, which comes to the negative side of these capacitors, on the negative side of the battery, you'll see a massive change in the voltage rising coming through one wire to the circuit. So I'll connect that and I'll place this here next to the meter so we can see that, and it's connected now. Now I'm going to short that out there now because it gets dangerous very, very quickly, and I don't want to blow up the meter, so I'm going to disconnect the meter. So we're at 250 volts there, and that happened in a matter of seconds. Okay, so that's real. We'll put that meter back on. Alright, we've jumped back up to 20 volts. If I place the white jumper lead back onto the negative, so negative of capacitor to negative of the battery, that is now the only connection for the circuit to the capacitor, and it climbs reasonably fast. And so if you were thinking here, I don't have to worry about the capacitors, I only have one wire connected, surely they couldn't charge, like I said, you might end up getting a bit of a rude shock when 340 volts gives you a little bit of a punch. And that's still climbing. So now if we were to come over, you know, through the bridge rectifier to this lonely little coil here, we can see that the radio field is now coming back through the bridge rectifier from the other earth ground, and this makes this, the rest of this system is live now as well. So if we have a look at the capacitor, the neons light up anywhere near any of these wires now. So, you know, it's just not safe to think, oh, things aren't connected, it surely can't be receiving charge, when clearly it can be. So we've got that coil, one wire to the negative battery. It's still slowly climbing, but it seems it wants to hang out there at 360. So if we were now to grab this coil with my hand, I'll put my hand on it and I'll go back to the voltmeter to show you. Hand going on now. And so I've just got my hand sitting around the coil, actually touching the outside of the coil. I've got tape wrapped around it. Again, you have to be so careful. Even doing this could be extremely dangerous if those bridge rectifier components failed and it started feeding that voltage back to me. You know, that could be disastrous. So here we are, you know, with a reasonable distance between the main coil and that coil, but some of its power is being fed through that single wire. So now if we were to take the this single coil here and implement a second earth wire, and so we place that in next to the main coil, and you can see that with the light it actually intensifies. There's also a small spark when I make contact, but the voltage also goes up considerably. Yeah, so I think, you know, just before showing you how to wire this up, it's probably a good idea to make people a little bit more safety conscious. You know, so that I don't be the cause of someone's unfortunate death. So that's practically it. I'm not going to short that out at 900 and something plus volts. It's just interesting to note that whilst you would think in, you know, even normal circumstances, when this capacitor arrangement is not connected to the circuit like that, it can still get up into the hundreds of volts and can still cause some serious harm. And you know, maybe get yourself some of these neons, and you can move them around your coils and work out what's safe and what's not, and you know, just how far. I mean, these neons don't display at a large distance, you know, or get that far away from the coil, and they stop. However, you know, we can have the coil way over here, and so we're currently looking at 760 plus volts. So I put my hand on the coil again, and it seems to go up pretty quickly, and again that would cause some serious pain if you were to accidentally short them out. Yeah, so just sort of bring that to everyone's attention just before showing you how to wire it up, because that would not make me feel good if someone was careless. I mean, you know, some would say liability issues. Well, we all get in cars every day, and you know that you can die that way. So I think it's important here that people know of the dangers so that they can avoid them, and if you behave yourself, you will be able to take advantage of these things. It's interesting to note, though, the effect that earth has. If we remove that earth connection there, and then we go back around with the neons, only one wire, and that's the secondary coil, and the rest of it has very little to no field visible to these neons. Put the earth back on, and so the last thing I'd like to point out here, in regards to safety, is just how dangerous this can be. I blew this light up accidentally the other day and blew the transistor just after filming the piece you were watching, and that was done late at night, and I foolishly, quite tired, came out and disconnected the main 240 volt light, this one that I was just running some tests on. So that is a 240 volt light with I think it runs on 11 watts when used normally. Yeah, 240 volt, 50 hertz and 11 watts. So a bit hard to see on the camera there, but that's that one I showed earlier in the video. So if we take that, as I was saying, I was running that light. It was the only light on in the room. I foolishly came out and disconnected the positive line here off the battery, and then, being that the light went out, I was in the dark, couldn't see what I was doing, and the positive lead of the battery dropped down onto the bridge rectifier and discharged over 900 volts from the caps, and that transistor is no longer with us. Maybe that one there. And at the same time, the power surged, wirelessly surged, in this coil that I had on the side there, just like those coils are. So, it's very important to be careful. The last thing I'll just show you quickly is using this light here, and in reference to earth connection and what earth can achieve. So we've got earth disconnected there, and I've connected the second earth via a jumper lead to the 240 volt light, and so if we go around the circuit, we can touch that onto the collector, nothing. Touch that on the positive terminal of the battery, nothing. We touch that on negative terminal, there's nothing. So if we now to take that earth connection and reconnect that, and repeat the same experiment. So we've got earth number 2. Now these are separated, these earths. They're we've got this one here, which is a 10 meter connection. It's 2 wires there, but I've twisted them together at the end so that becomes 1 wire in essence, or 2 wires parallel, but it acts as 1 cable, 1 larger cable when you do that. So that is 10 meters, and that goes into the ground, not very far down into the ground. It only goes about probably maximum 10 centimeters into the ground. And the other earth is the rest of that cable, that wire that I just showed you for earth 1, we'll call it. This earth is 90 meters long, and I obviously haven't unrolled. I've unrolled probably the same, maybe 10 or 15 meters of that, and that goes also into the ground to a depth of about the same, of 10 centimeters, and those two metal rods that are in the ground, I'll show in another video I'm going to do, where I stretch these out. The two metal rods are currently round about 30 meters apart in the ground, and then connected by 100 meters of cable, when you consider this is 90 and this section here is 10. So we've got 100 meters of cable there, and I'm going to stretch them out and place the two metal ground spikes 100 meters apart. And then, well, actually I'll make it more than 100 meters apart, because I've got approximately 20 meters of other cable already connected to a light, so we'll demonstrate that. So it'll be over 100 meters to demonstrate that it through the earth, and that just proves that it's not that difficult to do. I mean, this is all in Tesla's patents, and it's just a case of somebody putting the time towards doing it, or you can just copy this because I've already done it. So 240 volt light. Now we've got earth number 2 connected. Earth number 1 comes to this light. So now if we were to touch the collector, that operates quite nicely. Or if we go over here and touch positive, same, negative. Yeah, so we're looking at a 240 volt light there, being operated by, well, in essence, by a 12 volt battery. Without all the fancy chips and diodes and all the rest of it that 9 out of 10 circuits will have you put in, that's just using earth and taking advantage of earth. There's obviously a lot more power there than what we realize. And yeah, so now we'll go on to how I've wired this up. I'll put the camera in a better position so I can display that and explain to you which wires are what. All right. Okay, so this will be the last bit I do on safety in regards to this. I need to point out, while I remember, don't connect this circuit. Well, I wouldn't recommend you connect this circuit to any lithium batteries that have battery management systems. It'll blow that battery management system out of the water, and then you've effectively got a dead battery. I have stuck this circuit on lithium batteries before that weren't using a battery management system, and they inflated like balloons. So something in this system that maybe from whatever the earth potential was, or extremely high voltages, or what, I'm not entirely sure, but the battery was no longer usable. And so it's very important to keep it away from most electronics. It'll destroy some of your meters, That one has already copped a nice high voltage spike and is already presenting some signs of damage. So I'll just quickly do this last little segment and then we'll move on to wiring this circuit up. Just remember, your safety is your responsibility. This can, if left unattended or whatever, can reach serious potentials that can cause serious harm. If you've ever got capacitors in range of this circuit, and that is in range, I mean, that's as much of a disconnect as you need to get serious hundreds of volts worth. So if you ever have caps nearby, it is a good idea to have them shorted out. So just one wire that you connect to both terminals and it keeps them at 0 volts. So maybe what we should do is just demonstrate the wireless potential of this little tiny coil here. I've even shorted out that coil there. It doesn't seem to make too much of a difference for this demonstration. So we've got the small coil coming to the bridge rectifier that we've seen before, going straight to the caps. Voltage is 0 because we have the jumper lead across them. I'll disconnect that jumper now, and we should be able to watch that voltage rise reasonably rapidly. So I can't remember exactly what voltage that gets to at that distance. If I short that out, we can see that that is genuine and that she climbs up again, and we can short it again and it'll just keep doing that. So that's with that coil sitting at a small distance away, and it does it relatively quickly. Alright, so now if I take that little coil and I place it on top of the battery, because remember, all of this stuff has that field around it now. So if we take this little coil and place it on the battery, it will be receiving that field, and now we're up getting into the hundreds. I'm going to short that before it gets too big. And just show you how quickly it climbs. So, you know, that'll go quite rapidly, and if we allow that to get to its full potential, doesn't take long. I think it sits around about the 360 volt range. I'm not really willing to discharge that because it'll probably kill my meter, and I can't afford to get a new one. So maybe we'll do a once off just to prove that it is super dangerous. I'll disconnect the meter so it's safe. So what are we looking at? 300 volts. Should not be doing this. Okay, meter disconnected. Brace yourself. Okay. I don't like doing that. That is not safe to do. But I need to do that to point out how dangerous these things can be, and they don't comply with conventional theory of electronics. So, yeah, like I've got no meter on that now. I'll guarantee you that's back up. Oh no, I disconnected it. Okay, so it's disconnected from the bridge there, so it's no longer receiving charge. But we put them back on. And you got to be careful when you're connecting everything as well. It's not too safe to do it whilst filming. And so we've already got voltage. That's just using one earth wire. And that coil just sitting on top of the battery. So, you know, as you saw, even at that distance from the coil, it'll still produce a decent amount of juice. So yeah, all right, onto the winding, the wiring section of this video to finish it up, because this has taken way too long. But I'm super worried that someone is going to think they know what they're doing and end up killing themselves. So I'll just try to point out everything that I'm currently aware of, and I will say there are some things that I am not currently aware of, and you need to factor in those things too. So treat this like it will take your life, and you should be fine. You know, if we didn't take risks, we'd get nowhere. So, all right, onto the wiring bit. So finally we get to the wiring section for this coil. If you've skipped the safety components of this video, that might have been a very foolish move. I would go back. I'd highly recommend you go back and watch the first part of this video and the other two videos in this three-part series, because this can be very, very dangerous. I do not want anyone to get hurt with this. I don't want anyone to assume they know what they're doing with this, because you will not find a lot of this circuit's features in textbooks. You will not be able to learn about it in any other way other than experimenting yourself and, you know, watching those safety hazards that I'm already aware of. As I said before, there are plenty that I'm not aware of. So without further ado, let's get into this. So this is the circuit that I was winding for the coil that I was winding for the start of this video. Got up to 4 turns. I haven't finished it because I'm slow like that. But what I did is I placed on this coil, on the start of it, the red and black heat shrink, just so we can identify when we get to the end of winding this coil, we're going to connect opposites together to make a bifilar primary coil. Okay, so when we get to the other end, we'll have these 2 wires. One will be black, one will be red. We're going to connect the red to the black. Okay, that's very straightforward. So because I have finished this other coil that you've seen in the rest of the video and before, in relation to safety and whatnot, this one is finished. This one's 180 turns. And so I just pulled apart the circuit and placed upon those wires the black heat shrink that you see here on these 2 wires, and that was done so that we can simulate the other coil that I'm not yet finished winding, but we can use that whole concept. So we started with two wires, these two here. Oh, sorry, that's the end of the primary coil wires, and this would be the starting point of these two here would be the starting point of the primary coils. So what we're going to do is we're going to go through junction by junction on this terminal block and reference it to the schematic, and we'll try and make it easy for everyone to wire up their own. Okay, so first junction number 1 is the beginning of the coil, and I've used the red of those two leads. So remember, we've got these two that are the actual beginning of the coil. I've taken the red one and placed it in terminal number 1. The other side of terminal number 1 is this wire that I've stripped from some other device just because it had a ring terminal on there, and that makes it easier for me to connect it just through the little bolt and straight onto the collector of the transistor. So the first wire is from the start of the coil, and that goes through to the collector of the transistor. As you can see on the schematic here, I've drawn a little picture of the transistor. Those are its labels for the junctions. So we've got the base, the emitter on that right hand pin, and the collector itself is the body of this transistor. And I like using these ones because they're metal. They will dissipate a bit more heat than some of the other transistors. I can bolt that directly to this heat sink, and that allows it to dissipate enough heat to keep it nice and cool. Depending on what load you're running, it will run hot, not normally with the loads that I've shown you in the video so far. So that's a collector. Junction number 1 comes from the start of the primary bifilar coil, and we want to use the red wire through to collector. Junction number 2 is the output or the end of the secondary coil. You can see here it comes just from the output there, so from the outer edge it's the end of the secondary turns, so the end of the 180 turns. Okay, that comes out of the coil into junction number 2, and then I've placed the base of the transistor in junction number 2. So those two pins just slide in straight into number 2 and number 3 junction. Okay, so that's very straightforward. So secondary coil output into junction number 2 to meet up with the base pin as shown on the drawing there. Junction number 3 is the emitter. So we can see here on the schematic we have the emitter, junction number 3. On the other side of junction number 3 we have this jumper. Okay, and I place the black on it to signify that that is also connected to the negative, and usually, well, in this circuit at least, the emitter is connected to the negative of the battery. So we can see that junction number 3 comes out of transistor's emitter into this jumper, which then goes across to join into this. And the reason why I've used these jumpers is this sized wire doesn't fit too well with any more than 2 of those wires in one junction. It gets a little bit hard to fit those in there, so I've made a jumper, and that allows me to have more connection points to that same point in essence. So junction number 3 is connected via the jumper to junction number 6, and then that corresponds to a negative line. So we'll talk about that in a second when we get to it. So junction number 4, it is the joining of the start, or sorry, the red one here in this position is coming down here to the end of the primary coil. Okay, so junction number 4 is joining of the end of the primary coil and the start of the primary coil. Okay, so those, basically what happens is the power comes in through junction number 5, it goes through the coil, across to one side, comes out through this wire here, and then back through the coil again. So it comes in, goes across, comes back, goes across again. Okay, and when it comes out the second time, it's going to junction number 1. So this is where we're connecting those two opposites. So we've got the black and the red. It's a good idea if you use separate wires, then you just know when you're winding your primary, we're just going to connect the two opposite wires. So we're going to connect the black to the red. That goes into junction 4, and you'll notice there's nothing coming out the other side of junction 4. You can put a wire in there and receive a slightly higher voltage than the input voltage, because it's in essence halfway through that coil. Okay, so you can tap off a higher voltage there than your input, so you know, not a lot higher, but higher. I tend not to use it. It draws quite a lot of extra current if you set it up that way. So junction number 4, purely just to join the primary bifilar. Okay, junction number 5 is your positive lead to the battery. So the positive lead to the battery comes in, it joins with the black side, which, if we follow that through, is the end side of the primary coil. Okay, so that's pretty straightforward. Junction number 6 is this jumper. So it comes from the earth, from the emitter here off the transistor comes to this point, which the corresponding side of is your negative to the battery. Okay, we're taking advantage of this jumper concept again and jumping across to number 8, where we'll get to that in a second. We'll do number 7 next. Number 7 is the start of the secondary coil. Okay, so the start of the 180 turns. It was started on this side of the coil. Okay, so that's pretty straightforward. The other side of junction number 7 is going to the high voltage light. So we've got this wire here, we follow that through, and you can see that terminates into the base of this light fixture. Okay, so that's junction number 7, which is the start of the secondary coil. This wire here coming through junction number 7, coming back to become one of the terminals for the high voltage light. Junction number 8 is the other side of the high voltage light, which is connected to the negative side of the battery via this jumper. Again, it's just too difficult to put what would be 4 wires into one position here. Or maybe 3 wires. It would just make it too difficult. So these jumpers should be the same in length, because we're always considering that resonance issue, but and I believe these are the same. That's why this one sticks out. It goes a shorter distance this way. So but that's pretty much it. There's not much more to this. Follow the schematic. I've placed on the schematic here the black coming out of those lines, so that's the bifilar connection there, that's that one there. We've got that black wire there, that one there. The red one next to it is that one there, which goes into the same terminal, junction 4. Okay, and then the other black, which is the end of that coil, is there. So pretty straightforward. Please be careful. Thanks for watching. Please like and subscribe. If you know anyone that might be able to work this out, if you're finding this too difficult, show this to someone. Please share the video. It'll make that algorithm work for us. There are a lot of benefits to this, but I don't have enough time to discover everything about this circuit. And there's so many more things that I'm not aware of. So, but again, don't take risks. We'll never achieve much. So yeah, thanks for watching. Have a nice day.